Hello, Weasels. We're back at it here. Hopefully, you've learned how to do synthesis and decomposition reactions. The next type that we will go through, you'll get the hang of pretty fast, but there are a few nuances with it, are called single replacement reactions. You'll notice that this is slightly different than double replacement reactions, so let's get into it here. Single replacement reactions are where one single element usually replaces another. You'll see why we call it single replacement, because usually we're going to have something come and replace another ion in that compound. Usually they consist of one single element and a compound, and that makes sense because that single element is going to go replace something. So a lot of textbooks will use this little example here. Now these are made up letters, but we have an element by itself, and then we have a couple or a compound. A lot of times I'll tell a story about this that maybe at Mr. Whitemore's high school prom, he had a date, and here's Mr. Whitemore, and here's his date. But all of a sudden, they get to the dance, and his date realizes he's not a very good dancer, and she sees another more handsome boy. And what's going to happen here is that this other guy is going to come replace Mr. Whitemore. So I really encourage you to show your charges when we do all this, but a lot of times I'll draw a bracket. Now keep in mind, a lot of kids would go, well, why wouldn't A go with B? If this is a positive metal, it would never go with another positive metal. A positive metal will go with another anion where it can lose those electrons, and now we have a new substance. A goes with C, and we have to crisscross their charges, but we've had this single element come replace this one, and then Mr. Whitemore is left by himself crying at the dance, and a lot of times this is how we produce certain metals. This metal would be left by itself. So let's do two examples here. Get out a piece of paper and follow along with me. One you'll see a lot. We actually do this reaction in class, unfortunately, in the fourth quarter, but if we drop some metal zinc into hydrochloric acid, all metals will always react with acid, but let's look at how and why. So here's kind of the work I would do. You'll always be given the words, and above it, we go write what we know. We usually can assume zinc's going to be +2. I know it's a transition metal, but that's just kind of the way it's going to be. But keep in mind, we're not going to write +2 down here because zinc will only be +2 if it's in a compound. This is just zinc by itself. So we got to go over, we have to remember, all acids start with H. H is +1, and hydro means it's just one other element, and obviously chloric is talking about chlorine. So here's my reactants. I crisscross zinc plus hydrochloric acid. Now if we go look here, we have a positive charge and a positive charge and a negative charge. So this negative is going to actually switch, and this zinc is going to replace hydrogen. So I go draw my little bracket here, and I have to be careful in my charges, because now if zinc is going to go with chloride, it's going to be ZnCl2, because I need two chlorines to cancel it out. And then who's going to be left by themselves at the dance? That's Mr. Hydrogen. But we have to remember, now that it's by itself, it's hydrogen, so it's diatomic, and this is why so many metals will bubble up when we put them in acid. They produce hydrogen gas bubbles. Technically, we'd need to go balance this really quick here. I can see, let me get rid of that. I have one chlorine over here, and I have two chlorines over here, so I know I'm going to need two hydrochloric acids. Now I have two hydrogens, which is great because that matches up with my two diatomic hydrogen molecule right there. That is an example of a single replacement. I would know it's single replacement because it's one single element with a compound, and it's going to come in and it's going to replace that other ion right there. Let's do one more example, but pay attention to how we do it. Another good example here. Silver 1 bromide reacts with pure magnesium. So if I go get started here, silver, Roman numeral is the charge, so Ag +1. Bromide's -1, so there's my first compound, and magnesium is my single element. So if I go get it started, remember, I'm writing my charges above it, but magnesium by itself does not have a charge. We can see this is going to be a single replacement reaction because I have a compound and a single element. And now we go look, and we have a positive, a negative, and a positive, and then we can see bromine is the negative that's going to have to choose between silver and magnesium, and in this case magnesium will come replace it. I show that with my brackets right there, and now I can see I'm going to make Mg +2 and Br -1. You'll notice it is not Br first because what always gets listed first is the metal. Don't make that mistake. The positive metal always comes first. I crisscross nice and easy right there. There's my first compound. I can see that magnesium replaced silver. A lot of kids will stop right here, but remember, if magnesium came and stole bromine away, who's left by themselves at the dance? That would be silver in this case, and it's going to be left all alone. And in the bottom of this beaker, we'd see some silver start to form if this was the case. We'd need to go balance it, and then we'd be good to go. That's the first part of single replacement reactions. We'll go learn tomorrow about the activity series and how we decide which metal to go with. Is bromine going to stay with silver, or is she going to stay with magnesium? But for right now, just assume all of your problems do. Check back in tomorrow. Don't forget, one more tip, any reactive metal with water always explodes. We've watched videos of sodium exploding when I throw it in a lake of water. A lot of kids think that Na and H2O, for example, the Na will go with the oxygen, and that's not true at all. I'm not going to tell you the answer, but for right now I'm going to give you a big hint. Instead of writing water as H2O, write it as HOH, as in this is a hydrogen ion and this is a hydroxide ion. Make sure to give that a try. Pay attention to any explosive metal with water, and otherwise get started on assignment 4. Don't forget to write your charges and be careful with your crisscrossing. Draw a bracket to show your new thing, and figure out which element's going to be left by itself after that single replacement.